How many people here have heard of ARM? Roll ahead. Okay, great, good. Sometimes they go in a room like, ARM, what? But anyway, HPC in a way is a very new market for ARM, even though we have been engaging towards the deploying an HPC for about 5 years now. My particular organization, I'm the HPC segment manager for the business segment team. This is a technical marketing business development group that we spun up over the last couple of years to really focus more on the go-to-market activities, move away from the, we still have the research engagements and the architectural engagements, but moving more towards how do we get our partners to start selling into this space. Is that going? No? Try that, okay. Long-term, and this has really happened over the last several years, is ARM is engaged worldwide in HPC. Obviously, HPC is geocentric in a lot of ways, and I appreciate the intro that Hyperion did this morning, sort of covering these areas already, so I won't go into too much detail here. A lot of our engagement has been around ARM research and ARM architecture, collaborating, looking at the different proxy apps, looking at the representative codes to see what can we do with our architecture moving forward, knowing that we want to move into this space. So a lot of research has gone on over the last few years to in knowing that, hey, we want to be in those exascale or pre-exascale activities. Yeah, I don't know if that does anything, so I'll just leave that there. Some near-term news, just as a way of an intro as well around the ecosystem. We have a couple of press releases came out in January with some early deployments, things that are going to be happening in 2017. As we see partners finally reaching the point where, hey, we've got actual silicon end systems that we think are going to be very viable in the HPC space. So this is sort of, we're in that tire kicking phase. We've had people come out with silicon already where it's more of a software effort, porting over codes, validating, things like that. But now we have actual silicon that we think is going to perform quite well and really be able to define our success going forward. And that begins again in sort of the second half of 17 with some significant partners. Get this thing up a little higher, sorry. And then, of course, with Japan, we're collaborating heavily around exascale as our post-K system is under development. This was announced at ISC 16 last year, and then also at Hot Chips, we had a further dive in it in regards to our scalable vector extensions, which was an optional extension to our architecture that was basically added just with the intent to enable exascale and HPC performance. So on to ecosystem, which is one of the main the functions for IHAV is to chase the ecosystem. From ARM, we as a company, last year I think we shipped 17 billion different processors across a variety of industries around the world, HPC being a new one. So as a company, we do value ecosystem. We define an architecture, we define and license IP in support of that architecture, but we also drive an ecosystem, a software ecosystem in support of our architecture. From an HPC standpoint, we look at it as both commercial and open source entities. We don't pick or choose. We let the end customer define what they need, what are the requirements. We work with all the major labs. We work with academia. We work with industry to define, okay, what do you need in the different spaces? And then we cross a lot of different foundational boundaries to bring those pieces to the market in support of our partners' products and silicon. And so this is a real high-level list. I'm happy to dive into anything and much more. I've got 10 minutes to run through this, so I'm going to keep it very high level. But again, we do focus on both commercial entities, and from a commercial standpoint, we have both ARM commercially supported products targeting HPC, as well as we work with companies such as Bright, or RogueWave. Alinea is a company that ARM acquired that is a leader in debugging and analysis tools that supports HPC across all architectures, actually, not just ARM, obviously. But it's glad that they bring a great deal of expertise. But again, we push forward in both commercial and open source spaces. Not sure what that was. There we go. Quick blurb on OpenHPC. I won't stalled here too long because you just had the bit. Other than, the 1.30 release just came out. ARM has, we're tracking every release as well that comes out with our own build of it available online. Shout out to Suse who helped us stand up our build at the TAC Center in Austin. And we also collaborate with both Suse and Red Hat as we drive forward in the ecosystem in that regard. On the technical steering committee, and yes, silver member there. Generally, what we see from an open HPC, we aren't driving at this point a commercial product, such as an orchestrator off of this. We're looking, this is providing a nice baseline set of codes. It gets our engineers also to work through the build processes themselves. What we've seen is with our ecosystem and our tool chain becoming more stable over the years is, hey, go through the process yourself, porting some of these over, make sure that you can run the builds, identify any gotchas, but really we've seen it, everything sort of flows fairly easily and straightforward. So as people in the industry port more of their open source tools, ones that aren't in open HPC, we have the expertise, and we feel it should be a fairly straightforward process for anybody doing that. From a commercial standpoint, ARM is also building their own software stack that we can commercially license and support deployments. Obviously, not everybody wants to just run open source. They need something supported out there. So this is the current list that is available for the ARM architecture today. We've talked about this at SC16 last year, and then we drive through these through our DSG organization over in the UK. And we do have actually some specific tools targeting SVE, which is the scalable vector extensions for those exascale projects down the road. Silicon doesn't exist today, but we've got the compiler and the emulation support available for those folks that want to kick the tires on what that means for their software. We have other tools like Code Advisor that are integrated with our compiler tools that help drive greater parallelization and use of vectorization in people's codes. And we have the new Linea support for ARM with their debugger and their analysis tools, which we think is a very important part going forward. Quick slide on our compilers. Again, if you notice, it says C, C++, Fortran. If you want a solution today for Fortran, you've got G-Fortran through the GNU tool chain. That is very solid and works well. But we also have Fortran in the works from a commercial standpoint. I can't talk a lot more about the details on that other than there's obviously some ongoing PGI flying collaboration that's been talked about publicly back at SC, and we're working on leveraging some of that towards a commercially backed Fortran compiler as part of the HPC compiler solution from ARM. Performance libraries we've actually had out for about a year and a half now. Again, the basics of BLAS, LAPACK, and FFT optimized for our partner Silicon. One of the key things about ARM is we enable IP that defines certain cores and things, and we will support those, but we also license the architecture, and we will enable our partners who have gone and designed their own microarchitecture. We've also enabled that we will enable optimizations for those specific microarchitectures of our partners to get the best performance out of it and provide these as a supported commercial product. While our partners also work to drive open source versions out there, the open BLAS and other things will get enabled for optimizations going forward. Hop through, going fast. This is just a real small snapshot. What we've seen over the last year or so is more and more people like the XNS projects and other things that are happening. They're just porting the existing applications over, the open source ones, and they pretty much just work. There's not a lot of refactoring, anything that has to go on. It's more about getting the build right with our tool chain than anything else. But we are driving more resources within ARM to collaborate with end users if they have a need, especially around open source, to get things ported and optimized properly. And then with Linea coming on board, we have actual resources that can dive in even deeper and collaborate with major end users to do special optimization work for their particular applications. Let me pop through. So that was it. I wanted to go through sort of fast, give you a quick blurb on it. There's tons of places you can read, or I'm glad to follow up one-on-one. We do a lot of engagements at SC and ISC. We have workshops at ISC 17, at SC 17, diving into users' experiences, as well as more detailed dives into our overall software ecosystem. So please contact me or follow up later. And any questions too? Right on time.
What about support for other scripting and programming languages like Scala, Lua, and Julia?
We drive support for all those as well. OpenHPC defines some of those, but we don't limit our support to just what's in OpenHPC. Sorry, I didn't make that clear. That's a subset of every. We'll drive anything that's prevalent and that people want. So yeah. There's obviously alongside HPC is just the straight data center. We're within ARM, we have actually a lot more resources driving along a lot of those tools. Things like containers absolutely supported, things like that going forward.